Let's review the story of finding domains of functions and add to the story a little bit. So first recall what the domain is. Okay, so instead of just saying that the domain is input or domain is the x or something like that, we should use a longer phrase. So at minimum something like the domain is the set of all x, or the domain is all of the possible inputs or all of the valid inputs. It's this collective thing. It's all of them together, all the inputs together that work. So in a little more words, the domain is the set of all real numbers, which can be used as input, that produce a real number as output. By default, the domain of a function is all real numbers, unless there's something that creates an exception. So, for example, the domain of f of x equals x cubed plus 3 times x plus 6 to the x power. The domain of that is going to be all reals, and that's written negative infinity infinity in parentheses. As an exception, we've already seen functions with fractions. The thing is, when the denominator is zero, uh, uh, the value of a fraction is undefined, so therefore the value of your function will be undefined. Therefore, we have to avoid the situation when the denominator is zero. Avoid the denominator being zero. We now have a new exception to deal with, and this is a function with square roots. Now, recall that square rooting a negative number produces an imaginary number, and up here, we want to produce a real number as output. So the contents inside a square root should not be negative. Or said differently, we want the contents inside a square root to be greater than or equal to 0. So the first way it was worded was more an avoidance of the contents inside a square root should not be negative. So what we really want to have happen is a thing where square rooting needs to be greater than or equal to 0. So in this small example here, in g of x equals root x plus 3, we need the contents inside, which is in this case x plus 3, to be greater than or equal to 0. So if we set up x plus 3 greater than or equal to 0, subtract 3 on both sides, we'd have x is greater than or equal to negative 3. So let's try this example. Find the domain of f of x equals 2 plus root 3x plus 12. Again, we want the contents inside the square root to be greater than or equal to 0. Now the contents inside the square root here is just the 3x plus 12. So the root tells us where to look, but we look inside the square root, and we say 3x plus 12 should be greater than or equal to 0. Please don't write root 3x plus 12 is greater than or equal to 0. That's missing the point. That's missing the idea that it's the thing that you're square rooting needs to be greater than or equal to 0. So take 3x plus 12 is greater than or equal to 0, subtract 12 on both sides. You have 3x is greater than or equal to negative 12, and then divide both sides by 3, and you'll have x is greater than or equal to negative 4. Now recall that we could have written the word want each time, but it gets a little much. We want or we need x to be greater than or equal to negative 4. So here's a picture on a number line, and the domain is bracket negative 4, comma, infinity, parenthesis. Let's do another example. Find the domain of g of x equals 31 minus root 6 minus x, all divided by x squared plus 2x minus 15. So just to make a quick list of the things we need to avoid and the things that we need or the things that we want, we need to avoid when the denominator equals 0. So notice here it's avoid x squared plus 2x minus 15 equals 0. It's not just avoid 2x, it's not just avoid x squared plus 2x minus 15. What would it mean to just avoid the denominator? So it's avoid the situation when the denominator is equal to the number 0. We also want, or we need, the contents inside the square root. In this case, that's 6 minus x. We need that to be greater than or equal to 0. So taking the first part, we can factor, apply the zero product property, solve each of the little equations. And again, just remember what we want is to avoid. So just wrote the word again one more time as a reminder at the end here. So we need to avoid when x is negative 5. We need to avoid when x is 3. Now let's take a look at what we want. Remember it was 6 minus x greater than or equal to 0. We can add x to both sides, and if we want, we can flip the direction of everything. So just writing the x on the left, so x less than or equal to 6. So take a look at what we need to avoid. Take a look at what we want to have occur. So x must be less than or equal to 6. But in addition to x being less than or equal to 6, there are two numbers that need to be avoided. So we need to sort of the different parts of this create different exceptions, but we need to make sure that we don't use the number negative 5. That has to be avoided. 3 has to be avoided. So we want all the numbers up to and including 6, because of the root, but then we also need to avoid two of the numbers. The root itself wouldn't care about using x equals 3, but the denominator would be a problem. If x equals 3, the denominator would end up being 0. So here the domain is, for the first part here with the arrow on it, it's parenthesis negative infinity comma negative 5 parenthesis. And then the next line segment to get that, so we'll union and then have parenthesis negative infinity comma 3 parenthesis and then a union symbol again. And then for the next little line segment, the part between 3 and 6, we'll have parenthesis 3 comma 6 bracket. The only place there's a bracket is by the 6. That is the only number that's being included.